Okay, so in this lesson, we're going to look at finding where a function, looking at a graph where a function is increasing, decreasing, or constant. So we're going to be writing intervals where it's increasing, the intervals where the function is decreasing, and the intervals where the function is constant. We're also going to look at some problems where we're going to look to see where the relative maximum and relative minimum are located. Okay, so let's look at the idea of increasing, decreasing, and constant. Now, keep in mind that when you read a graph, you read it from left to right. When you read a graph, you read from left to right. Now, notice some of them will have arrows, and some of them will have a closed circle or an open circle. So there may not be arrows on both ends. Okay, so as I go from left to right, listen to this carefully. As I go from left to right in terms of going across the x-axis. So notice I'm going across the x-axis. I'm going from negative infinity to infinity in terms of the domain, okay, along the x-axis. So as I go along the x-axis, think about what the y values are doing. What are the y values doing? Okay? So as I go along the x-axis, so as I'm going along the graph, my y value, see this y value and this y value and this y value? Those y values are increasing. So this y value is 0, this y value is 1, this y value is 1.2, and so on. So my y values are increasing. Then all of a sudden, notice these y values right here. All these y values are the same. They're all 3s. So notice that I'm increasing. Then my y values are constant, and then all of a sudden my y values are decreasing, and the graph stops at 8. Okay. Well, when x is 8. Let me rephrase it. So my y values are increasing, constant, and then decreasing. Okay. Over here, as I go from left to right, notice the arrows on both ends. So my y values, just trace along the graph. My y values are decreasing. Y value here is 6. Y value here is 5.3. The y value here is 4, and so on. So notice they're decreasing. Then all of a sudden, it goes from decreasing to increasing. And it's increasing, increasing. Then all of a sudden, it goes from increasing then to decreasing. My y values are decreasing. Okay? All right, so that's how you read it. Make sure you understand how to read a graph and you go from left to right. Okay, so let's talk about where the function is increasing. And then you're going to write intervals for that. Where it's decreasing, and then where it is constant. Okay, so remember they're going to be intervals. Now keep in mind that the intervals you write will be elements of the domain. So remember, the domain is a set of x values. So listen to this. As I go from negative infinity, and you may want to use colored pens if you need to. It's up to you. But you're going from negative infinity to, okay, now what I would do is this. I would say increasing, then this is where it changes. So I would just do something like this. All right. Just make a little line like this. Then from here to here, it's constant. My y values are constant. Do another mark like this. And then all of a sudden, the rest of it is decreasing. Okay? So notice when I did this, I separated the x-axis now, into 3 intervals. That's important. I separated the x-axis into 3 intervals. This interval, this interval, this interval. Notice that from here to here, from here to here, my y values increased. Okay, they increased. All right. From here to here, my y values were constant. Okay, and it helps if you write this out like this. And then from here to here, my y values decreased. So my function is increasing, decreasing, constant, and then decreasing. Okay. All right. So here's how you write the intervals. Remember, you're gonna use um, the the domain as your intervals. All right. You're gonna use your domain as your intervals. I'm trying to color the x-axis differently. All right. Okay. So and remember this is an arrow here, so the arrow keeps on going to the left, so that means you're in terms of reading the graph. Remember when you found domain and range, you went from negative infinity to, all right, so listen to this now. From negative infinity to this x coordinate, which is, remember right here, you can see it, it's -2. -2. And remember, you're just talking about open intervals, so you're going to use parentheses there. Whenever you talk about increasing, decreasing, or constant, you're looking at open intervals. All right, so it will be parentheses always, regardless. All right, and then it's constant from where? Well, it's constant from this x coordinate, x value to this x value. So this is -2, and this is 3. Okay. So you're going to say from -2 to 3. That's where it's constant. And then it's decreasing. Now remember, that's not an arrow right here. That's a closed circle. So you really need to kind of do this right here. All right. So it's decreasing from this x value to this x value. So it's decreasing from 3 to 8. And that's it. That's all you do. All right, but notice how we did this. Again, you read a graph from left to right, increasing, constant, decreasing. So my function is increasing here, my function is constant here, and my function is decreasing here. Now keep in mind what we mean by why is it increasing? Well, it's increasing because the y values, what I mean by that is that the y values are increasing. So remember, your function is f of x. Remember, another f of x means the same thing as y. So when we say function, that's f of x, which is y. So my y's are increasing. My y's are constant. They're all 3's right here. Everyone's 3. And then my y's all of a sudden start decreasing. Okay? All right. So when you write your interval notation, though, you're using the x values that correspond to that. So that's why you see me coloring the x-axis. So it's a very good idea for you to do that if you can't see it visually without doing this. Draw these lines where it changes from increasing, decreasing, increasing, constant, and so on. Okay, so from increasing, and then all of a sudden it's constant. I'm gonna draw a line where it changes. Make sure it goes through the x-axis because you need that. Then it's constant, all of a sudden it changes, and then it's decreasing, and it stops here. So since it stops, since there's no arrow, I'm going to put another little line here. Then you color the x-axis if you need to. Color different colors. So from negative infinity, see how this is an arrow goes towards, it keeps on going. So from negative infinity to where it changes, my function was increasing, my y values were increasing. From here to here, from this x coordinate to this x value, x coordinate, my function's constant. So I wrote the word constant. And then from here to 8, my y values were decreasing. So I wrote the word decrease. And then I used those x values, those part of the domain, to write the intervals. Okay? All right, so let's look at this one. And it's very simple. It's really not that difficult. Okay, so here, remember these are both arrows now, and they're using, okay, that's an F here. So again, this is still f of x. Sometimes they'll use a different letter. All right, so so from, remember, you go along the x-axis. So from negative infinity, see, this is an arrow, keeps on going. So from negative infinity to this, so it's decreasing, so my y values are decreasing. Then all of a sudden here, right here, is where it starts increasing. So I'm going to draw a line like this. Okay? And so so my y values are increasing, increasing, increasing. Then all of a sudden it starts decreasing, and then it starts decreasing here, and then we're done. And then the rest of it's decreasing. Okay. So in terms of the x-axis, you would color this, and then from negative infinity to -1, my y values are decreasing. All right. And then from -1, -1, let me use a different color. So from -1 to 1, from -1 to 1, my y values are increasing. Okay. And then from 1, let me see if I can get another color. From 1 to, and see how this arrow, how there's an arrow here, so it just keeps on going. So from 1 to infinity, my y values are decreasing. Okay? All right. So now I can answer the question. So, where is it increasing? Let's see. It's only increasing from here to here. So again, open intervals. Always open intervals for increasing, decreasing, constant. So from -1 to 1. Okay? Decreasing. All right, decreasing. And remember, it's increasing in 2 intervals. So from negative, see how this arrow, remember this arrow went up, so we drew the arrow here. So from negative infinity to -1, my y values are decreasing. My function is decreasing. So from negative infinity to -1. Union, make sure you put the word union. Union from 1 to infinity. Okay? Constant. Notice my function wasn't constant anywhere, so you say nowhere. Nowhere. All right? Okay, let's look at that. Now again, it helps if you color code this thing. It does help. Okay, so here, you can't see it very well. Let's see. So here, there are no arrows, but I am increasing as I go from, remember, you go from left to right. So as I go from left to right along the x-axis, my y values are increasing. So they're increasing from here to here. Then all of a sudden they're decreasing. They're decreasing from here to here. Then they're constant from here to here. Then they're increasing from here to here. And then it's constant from here to here. All right, so I'm dealing with, if you look at this, I'm dealing with 1, 2, 3, 4, 5 intervals. See it? This interval, this interval, this interval, this little bitty interval, then this interval. All right, so 5 intervals. So when I do all this, I have 5 intervals altogether. All right, so remember, there were no arrows, so you notice I started here. I drew a line, up and down line, where it started, and then where it ended, since there were no arrows. Okay, so again, it helps if you kind of help yourself label these along the x-axis. Okay, so notice, remember here, I use an arrow here, and then I use an arrow here to indicate negative infinity, and then over here that was infinity. See, negative infinity, infinity. This is because there are arrows on both ends. Here there was an arrow only on this side, so you only saw negative infinity here. There are no arrows, so I'm not going to use any infinity or negative infinity at all. So from here to here, I'm increasing. Let me just put INC. Okay. From here to here, I'm decreasing, so I'm going to put DEC. I don't have enough room to put all that. From here to here, I am constant. All right. Then from here to here, from here to here, my y values are increasing. And then all of a sudden, they're constant again. So from here to here, they're constant. Okay? That's how simple it is. It is not difficult. All right. It helps if you kind of color your axes and draw the lines like this. Okay, so your function is increasing. Let's see, it's increasing 2 places. So it's increasing from this x value. Again, you got to use your domain for this. You got to use your domain. So you got to say from -6 to -3. All right, open intervals. They're all going to be intervals. Union, and then they're increasing from this x value, which is, I don't think you can see it, but that's a 3 to a 4. Say from 3 to 4. Okay, now decreasing. Well, they're decreasing in just one place, from here to here, from here to here. So that's x value -3 to x value -1. So again, you must use your domain, -3 comma -1. And then it's constant, let's see, 2 places. So it's constant from -1 to +3, and then from +4 to +6. So it's constant from -1 to 3, union 4 to 6. And you're done. Okay, next one. All right, so you have 2 arrows here. So again, you read a graph from left to right. So as I go from left to right, remember the arrow keeps on going like this, okay? So you're going from -infinity. So from -infinity, so I have an arrow here. Let me kind of use red here. So you're going from -infinity to, and remember your function's decreasing. Your y values are decreasing. They're decreasing, getting smaller, 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 smaller. Then all of a sudden they start increasing. So that's here. So that's where it changes. Should have used this. So that's where it changes, right here. So from -infinity to this x coordinate, x value, I should say, your function is decreasing. Okay. Then all of a sudden, you remember it increased. So it increase here, and then all of a sudden it decreases. So from here to here, your function, from here to here, your function increased. Okay, your y values increased. From here is decreasing, all of a sudden it's increasing. So let's say it did it here. So from here to here, it decreased. And then the rest of this is an arrow. And remember what that means. That means that this thing right here just keeps on going like this. Okay, keeps on going up. Okay, so you're going from here to infinity. That's what's happening. You're going from here to infinity. So from 4 to infinity, my y values are increasing. So I'm put I and C here. Okay. All right. So now we're done. We just put all this in intervals. So notice there are how many intervals that we're dealing with. Let's see. There are 1, 2, 3, 4. 4 intervals. Decreasing, increasing, decreasing, increasing. Okay. So increasing. Just 2 places. So from this x value to this x value. So that's from 1 to 3. Union. And increasing from 4 to infinity. All right. Decreasing. Decreasing in 2 places. From -infinity to this x value. That's 1. Union. And from 3 to 4. Constant. Nowhere. All right. Okay, let's look at the next one. It's very simple. It's not that difficult. All right, so notice the arrows on both ends. All right, so you're going, as you read a graph, from left to right. So we're just pointing towards negative infinity. So as I go from left to right, my y values are constant. Then all of a sudden, right here, they start changing. So they start increasing, getting larger. My y values are getting larger and larger and larger. And then all of a sudden, it changes again. They become constant. All right. So constant, increasing, constant. Notice the arrows on both ends. So I'm not gonna put any more blue lines like I did here, okay, because of the arrows. But I do need for you to remember that when you shade in your x-axis, because that's the domain's what you're going to put in your intervals, when you're shading the x-axis, remember you're going from negative infinity to here. So that's negative infinity. So from negative infinity, negative 1 billion, negative 100,000, your y values are constant, all the way down to negative 2. Then all of a sudden, they increase. So from this interval to, or from this x value to this x value, your y values are increasing, and this was constant. So write the word constant here. And then from 1, know the arrow, so it keeps on going. So from 1 to infinity, your y values are constant again. All right, so I have 3 intervals to deal with. All right, so let's do increasing. So it's increasing from negative 2 to 1. Decreasing, nowhere. Constant in 2 places, 2 intervals I should say, from negative infinity to negative 2, union, and then from x equal 1 to infinity. Okay, next one, the last one. All right, so here we're dealing with a quadratic. We're going to graph quadratic functions very soon. But notice that as I go from left to right on the x-axis, my y value, and these are arrows right here. You don't see them very well, but those are arrows. My y values are decreasing. Let me kind of move this up a little. So your y values are decreasing. Then all of a sudden, right here, so I'm going to just kind of draw this thing to make it cross the x-axis, because I need this x-axis. All of a sudden, they increase. Okay? So, remember the arrow here, so the arrow's on both ends. So that means that from negative infinity to this x value, which you can't see, but that x value is a 2. That's a 2. My graph is decreasing. So you remember, you read a graph from left to right. So you kind of trace over your graph. Y values are decreasing. All of a sudden, the y values are increasing. And then from here to infinity, my y values are increasing. Okay? All right, so where is it increasing? Well, it's only increasing from 2 to infinity. Where is it decreasing? Well, it's decreasing from negative infinity to 2. Where is it constant? Nowhere. Okay? All right, so that's the idea behind increasing, decreasing, and constant. Notice, though, that as we went from left to right, we were looking along the x-axis. That was important. So that's why you really need to shade in your x-axis with different colors to help you. Okay? So it does help. It visually helps you to determine where's it increasing, where's your function constant, where's your function increasing, and where's your function constant. Where's the function decreasing? Where's the function increasing? It helps if you draw these blue lines like this, those vertical blue lines, where it separates the x-axis, then you use your different colors. Okay? Because that's what you got to put here. You got to put your x values here. Your domain goes here. Okay? All right. Now, let's look at the other idea. So remember, so we just took care of the increasing, decreasing constant. Let's take care of the relative maximum and minimum. Okay, so remember when go ahead and use this one here. Do you remember when we went from decreasing to, and all of a sudden increasing? That was kind of like a little valley right here, a little low point. So that would be considered a local minimum. So if you look at all these y values to the side of this, so if you look at this this x value, very close to where that lowest point is, these y values are bigger than this y value. See how these y values are bigger and these y values are bigger? So remember, it went from decreasing, your y value went from decreasing to became smallest, and then it started to increase. Over here in this little area right here, so that's why they call it local. We're using the word Another word for relative is the word local. So I'm just go ahead and put the word local. So, and I'll explain the locals. Most students can understand a little bit better than relative. So in this local area right here, so if it's localized, just in this local area, not the global area here, but this little local part here. So in this little local part here, my y values, see these y values, they're getting bigger and bigger and bigger. Then all of a sudden, the y this is the largest y value, which is at 2, and then they get smaller. So this right here, when you go from increasing to decreasing, that's a peak, P-E-A-K. So that's a maximum, a relative maximum or a local maximum. Relative, local, synonymous. They mean the same thing. Okay? And then that's it. And then it starts going down. All right? So right here, let's look at this one. It's increasing, 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 and all of a sudden it decreases. So this point right here would be considered a local maximum. And then there's no other valley here. Um, well, okay. So there's no other valleys. There's no valley or peak. That was the only one. Here I'm going from decreasing to increasing. So this will be a minimum. This will be a maximum, local maximum. This will be a local minimum, decreasing to increasing. Okay. All right. So that's the idea. So let's look at this example here. All right. Now, so the direction says, and when you do my math lab, it's important you listen to this carefully. They want you, for each of the following, determine the following. The numbers, if any, at which the function has a relative maximum. And then they want to know what are the relative maximums. Okay? So the numbers, so when they say numbers, they mean the x values. Okay? So the x values, that's what you need to remember. When they say the numbers, they're talking about the x values. And then when it says what are the relative maxima, they want to know the y values. All right. So the numbers, if any, at which there is a maximum. So what x value gives you a maximum, and then what is that y value? What is that maximum value? Okay. So that's that maximum y value. And then the same thing here. This time they're talking about relative minimum. Okay, it's very simple. You just read the graph from left to right. So just like we did with this. So you remember you got to go from left to right though. Okay, from left to right. So as I go from left to right, my y values are increasing, 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 and all of a sudden they start decreasing. So this point here, this point right here, that point is a relative maximum. Okay? Then you went from decreasing, 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 all of a sudden it's increasing. So here's a little valley right here. So that would be considered a local minimum. Okay? Now, when you're taking calculus, there's something called absolute maximum, absolute minimum, or advanced, or something more advanced than this. So this is just called relative, but there is something called absolute. All right, so now what we're going to do is this. So let's do part A. Part A said the maximum occurs at x equal blank. So the maximum occurs at x equal blank. So what is this? So in other words, what is this x coordinate? You can't see it very well, but you see right here, that's 2, so this is 1. So it looks like when x is 1, I get this local maximum. So this right here is the point 1, 8. Right? So it helps if you label those maximums. So 1, 8. This right here will be 2, you'll see it? 2, negative 4. So that's the point 2, negative 4. It helps if you label this when answering these. It does help. Just like it helped when you labeled and colored your axes. All right, so the maximum, here's my maximum. The first part said the numbers, if any, at which the function has a relative maximum. So I want to know, what is an x value? Well, the x value, if you read it, that's just 1. Occurs at x equal 1. Oh, I'm sorry, I said 1, excuse me. That's 0 here, so that's negative 1. All right, negative 1. All right, see, that's negative 1. I wasn't reading this carefully. That's negative 2, so that's negative 1, that's 0. All right, negative 1. All right, and then it says, what is that relative maximum? What is that relative maximum? What they mean there is, what is that y value? So the maximum is, and then you just say your y value. So the maximum is 8. So that means that the largest y value in terms of this local area here is 8. All right, now it keeps on going. So that means there is no absolute. Remember, we're not talking about absolute here. The absolute, this is not an absolute maximum. It's just a relative maximum. There is no absolute maximum here because it just keeps on going up. All right, there is no largest ever possible for this graph because of the arrow. So we just say it's a local. So if you forget about everything else, get rid of everything else in this little area here, this is the largest y value you're going to get. Okay, so the maximum is 8. So the maximum occurs at x equal -1. That's where it occurs. And that value, though, that maximum value is 8. Okay. All right, B. So let's do the minimum. All right. So the minimum occurs at x equal. Again, it helps if you label the points at x equal 2. The minimum value, though, is this value right here, -4. All right, so that takes care of part of number 1, graph number 1. Okay, number two, let's go ahead and okay. So see how those are closed circles. We can leave it like this. Let's just leave it as closed circles. Okay, so I'm going from. So we have to talk about this in a moment, though. So I'm going from decreasing to increasing. So I know right away that this point here is going to be -2, 0. Okay, -2, 0. Then it increases, increasing, and so this local maximum. So that's the local minimum. This local maximum is going to be 0, 4. Your x value is 0, your y value is 4. And then decreasing, decreasing, then starts increasing. And then this right here is a local minimum, so that's 2, 0. All right, now let's talk about this. That's not an arrow here, so it stops. So if I cover all this part here, cover all this, see this right here? So when you talk about where the local maximum or minimum occur, you're looking at the y values that are close to it. So if I were to put this label this point here, that is -4, 2. All right. So if I look at the local part here, notice are these that I'm pointing to, are these y values smaller than 2? And the answer is yes. So that's going to be, now there's nothing on this side, so that's fine, but 2 is the largest, so everything else right close to it is, the y values are smaller than 2. So then this would be considered also a local, a relative max. This is a relative max. All right. It's easier to see if there's something on both sides. Increasing, decreasing, that's easy to see. Decreasing, increasing, that's easy to see. But when there's a dot, when it stops at the end, when it's a closed circle, it gets a little confusing. So here I'm going I'm just going increasing, all of a sudden I stop. So again, in that local area here, so remember this point here is going to be 4, 2 as well. Okay, so in that little area, if I cover everything else, in that local area, that's why relative means the same thing as local. In that local area, these y values, what do you notice by these y values? Are these y values bigger than 2 or smaller than 2? Well, these y values are smaller than 2. So this would be a local max. Okay, or a relative max. So that point's a relative max. All right, so let's answer the question. A, minimum occurs at x equal, maximum. Maximum occurs at x equal, and there's 1, 2, 3. Now notice that these x values are the same. I'm sorry, I was looking at y values. All right, so these x values are different. The y values are the same. So when we get to that part, in a little while, you're just going to put it once. So the maximum occurs when x is -4, comma, 0, comma, and 4. So there are three places where there's a local maximum. Now, what is that local maximum? So the local, or the relative, we could use relative this time. The relative maximum value is blank. Well, this one's 2, this one's 2, this one's 4. So the 2 is listed twice, you only list it once. So it's 2 and 4. Okay? 2 and 4. So there's a so in this little area here, that localized area, my maximum y value is 2. In this localized area, cover everything else, my largest y value that I see will be a 4. In this localized area, cover everything else. This little area right here, this local area, the largest y value I get is 2. Okay? All right, let's talk about the minimum. The minimum, so the relative minimum occurs at x equal blank. All right, so there are two places. Remember, these are your local minimums right here. Local minimum, here and here. Okay? So my x values here is a -2. This x value is a 2. So it occurs at -2, comma, 2. And then the question is, what is that local minimum value? That's what this part means. What are the relative minimum? That's your y values. Well, the y values for both of them are the same, so I just say the relative minimum value is 0. Relative minimum value is 0. And then you're done. Okay? So again, within that local area right here, if you cover everything else, the smallest y value is going to be 0. Every other y value, notice every other y value here is going to be bigger than 0. In this little area here, the smallest y value is 0. Everything else is going to be bigger than, all these other y values here are bigger than 0. All right, just letting you know, the see how these were arrows, and you don't have to know this for this course. But see how this was a local minimum? It also turns out to be an absolute minimum. That's the graph doesn't go any lower than this. So that's the smallest y value that you're going to get on this graph. That's the smallest. 0 is the smallest y value you're going to get on the graph. So those are absolute minimums. This right here, see how that stopped here? So there are no arrows. So this right here, the 4, happens to be the absolute maximum value. All right, but again, that's not in this section. So absolute meaning the largest y value possible, whether maximum, and then for minimum would be the smallest y value possible. Okay, and then finally, let's look at this one. So notice the two arrows. Okay, so I'm going from increasing to decreasing. So this point here, that point, would be a relative maximum. Okay, and that is the point -216. All right, so that's easy for you to see. Then I'm decreasing, and all of a sudden I'm increasing. So that point here is just the origin. That's 0, 0. All right. Then it's increased, and by the way, that's going to be a local, a relative minimum, relative min. Then all of a sudden it's increasing and then decreasing. So that point here is going to be which is 216. So that's going to be a relative max. And then the arrow keeps on going down. All right. So there's only three local maximum minimums. There are 2 relative max and then 1 relative min. Okay, so let's answer the question. Part A. The maximum, and when I say maximum, let's say relative maximum. Relative maximum occurs at x equal blank. So it looks, it occurs at x equal -2 and x equal +2. So -2 comma positive 2. Now I want to know what is that maximum value. So the relative maximum value, remember that's your y value, is blank. 16, 16. So you only list it once. Okay. Now just to let you know, you see how the arrows go down? This is the largest possible. So that's also considered, these two are also considered absolute maximum. Because it's the largest, that's the highest point possible. These arrows keep going down. And then the part B, the relative minimum occurs at x equal, and then this x value here, which is 0. And so you need to ask yourself, well, what is that minimum value? Well, the minimum value is 0, the y coordinate. So the relative minimum value is, and then your y value, which is 0. Now, you see how these were absolute? This is not absolute because these arrows keep going down. So you're never going to reach a smallest y value. Okay. All right. So that's the end of this lesson. So basically, what I wanted you to know is how to determine where a function is increasing, decreasing, constant, and then how to find the relative or local max or min. Okay. All right. That takes care of this lesson.